Okay, so this is our last unit. We're going to be doing scatter plots. We've done this before in Algebra 2. All right? So this is not new. But I'm going to take a minute to talk about the project. So we're going to do a project on chi-squared, then do Unit 4, and then do the linear regression chapter, and then do a project on that. We decided that we're not going to do this project, and at the end of Unit 4, your final project, you'll have a choice between doing a chi-squared project and a linear regression project. The chi-squared project is going to be a categorical one, so are you left-handed or right-handed? Do you brush your teeth in the shower? You can have some fun, and you can have some creative, funny stuff if you want. But it's going to be categorical. Yes, no, left-handed, right-handed, whatever. You have blue eyes or brown eyes. You do this or this, whatever. And you're trying to see if there's an association. Or you can do linear regression project, which is basically you're working with numerical data. How old are you? How many hours of sleep do you get a night? Something like that. Okay. How many times have you been to the doctor in the last year? How old are you? Whatever. And you can ask a variety of rules. So it'll be your choice at the end of this unit to do a chi-squared project or linear regression project. So let's keep going. This is very easy stuff. So first off, we can display two quantitative variables. Quantitative meaning numbers. All right? So numbers. Using a scatter plot. And again, this should be reminiscent from Algebra 2. We did this. First, though, you must decide which variable is your explanatory, your x, and which is your response, y. And you're going to decide, you've got to think about y depends on x. So if we think back just to, Algebra 1, 2x plus 1. And we would make an xy table, right? We would put numbers in for x and solve for y. So we put a 0 in here, we'd get a 1. If we put a 1 in for x, we'd get 3, and so forth. Y depended on what we put in for x. Okay? So, looking here, you don't have this written on your paper, so you have to add that in. Decide which variable is the explanatory and which is the response. So, square footage of living space versus price of houses. So you just ask yourself, is the square footage depending on the price, or is the price depending on the square footage? What do you think it's going to be? Yep. So price depends on square footage. The more square footage you have, the price goes up. So this is putting in for x, and then this is what we get for y. Y depends on x. Number 2. Average hours of study time per week versus average hours of extracurricular activities per week. This one's interesting because actually you could argue it either way. It depends on how you're looking at it. If you're looking at extracurricular activities as just being something outside of school, like hanging out with friends, you probably want to get your homework done first, then hang out with your friends. But if your extracurricular activity is a sport, or a play practice, or music practice, well, that comes first, and then once you're done with all that, then after you're done with that, you use the rest of your time to get homework done. So this one could go either way, depending on how you define extracurricular activities. So you write in how you want. If you play a sport, you might say study time depends on sports. If you don't play a sport, hanging out with friends depends on, you just do it either way. So that doesn't matter. Amount of rain versus crop growth. Does crop growth control how much rain comes from the sky? No. But crop growth depends on the rain. If you don't have enough rain, crops don't grow. If you have rain, crops grow. If you have too much rain, crops may die. Okay? That would actually be a negative parabola. I just wrote that in the wrong place. There you go. Nope, don't want to move that. All right, and the really easy one, height versus GPA. Neither. Right, oh, I think I heard, oops, wow, that was not right. Neither, I heard that. But I think I even heard a real good math term after that. I think I heard somebody say no correlation. I know it was you. No, but there is no correlation. They're not related. Your GPA does not affect your height, and your height does not affect your GPA. All right, so how will we go about making a scatter plot? You label your axes, scale the axes, which means put numbers on them, and then you plot the individual data. So, for this one, this is always much easier with graph paper. We're not doing this to be specific, exact. So, first off, we're looking at, is there a relationship between the amount of sugar in grams and the number of calories in movie theater candy? So first off, we got to figure out what's our dependent. Is sugar dependent on calories, or is the calories dependent on sugar? The amount of calories in the candy depends on sugar. Okay? So that means sugar is going to be our X, and the calories is going to be our Y. So when we make our axes, we're going to put sugar down here, X. Give you a little room for numbers. And we're going to put calories here. Now, when you're doing this, sugar, our lowest sugar looks like about 44 right here. And our highest sugar is 136. You don't have to start at 0. So you don't have to have this big empty space out to 44. But what you should do is add a little heartbeat monitor here. Just like if you was looking on a EKG. What that does, that little symbol, if you forget, I'm not going to take off. That little symbol says we're not starting at 0. So I'm going to start, and there's no right or wrong here. I'm going to start at 40 and go by tens. So 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40. That's good enough. Okay? Yeah, because 136 is the biggest one. So I'm going to put 40 here. If you don't have a lot of space, you don't have to put every number. You can skip them. 40, 60, 80, 100, 120, 140. That's good enough. Now, if you look at the calories, the lowest calorie is 350, and the highest is 790. All right? So I'm going to start at 350. Okay? I have a lot of space to cover, not a lot of space on my paper, so I'm going to go at 50s. So I'm going to go 350, 400, 450, 500, 550, 600, 650, 700, 750. I'm going to write in 350, 450, 550, 650, 750. If you want to write in all the numbers, you can. And now you're going to do your best job. Okay? Graph paper makes it so much easier, especially on a smart board. It's very hard to, you can't like draw your fingers across. So you just do your best. So 45, 450. So 45 is about halfway between 40 and 50. I'm going to go up to 450. That looks about right there. That's probably going to be the easiest one to boot. Okay? And now you're just going to do the rest of them. I'm going to hit pause. All right. So if you look at this data, 12 pieces of data, you can see it's generally going the same direction. Okay? You don't draw this on your paper, but you can kind of see, there's a general shape. It's going in a certain direction. You could draw a line through there. Okay? Now, what do we have out here? A point that doesn't really fit with the rest of them. An outlier. Very good. But you don't let that affect your data. Well, your analysis of the data. You don't say that it's not in there because that one piece. So, moving on. When we do this, we describe scatter plots with 4 characteristics. And the anagram for it is FODS, F-O-D-S. So, first off, we look at form. So, what we just did, is there a form? Is it linear? Does it look like a parabola or an upside down parabola? Does it look like an absolute value function, like a V? In this one, we would say, yeah, there's generally a linear form in there. Okay, there's a line in there somewhere. Outliers. Are there outliers? Well, we said that. Yes, there is an outlier in this one.
Do we have to say which one it is?
Not here. Direction. Is it positive or negative? Well, it's going uphill as it goes right, so it's positive. And strength. Now, this is the analogy. Remember me in Alpha 2, I said this, if you had me. I like to use the idea of a fly strip. Okay? So when you buy a fly strip, so you take the sticky stuff off, and there's like this yellow goo on it, and it smells, and the flies are like really attracted to it. At first, the flies are like just right there on it. In fact, they're literally on it. But they're really flying close to it. That's strong, because the scent is strong. As the scent wears off, you'll see flies kind of flying around it, but they're getting further away, because it's moderate. And then eventually there's just flies everywhere, because it's weak. It's not working anymore, it's worn off. So we use these ideas of weak, moderate, and strong. So if we looked at this and said, I'm going to draw a line kind of like there. Well, yeah, that would be moderate. You can see the formation of a line. They're kind of close to the line, but not very strong. So now our favorite part, we're going to write a sentence. So we're just going to describe using those 4 terms. And it's a very simple sentence. We're just listing words. There is a moderately strong positive linear correlation between sugar and calories with a possible outlier at 79,790. Now you don't have to put this part, but here, if we look at FODS, linear satisfies our F, positive satisfies our O, positive, D, that's our D, sorry. The outlier down here gives us our O, and then our strength is right here. The only thing you want to add, though, is here, you want to use context. Okay? So you want to talk about what you're describing. Okay, last but not least. Go away. So, if you remember from Algebra 2, we use the letter R for correlation. Correlation is a measure of the strength and direction of a linear relationship. Now, it's always between -1 and 1. Okay? If the relationship is negative, then R is less than 0. If it's positive, it's greater than 0. Common sense. Number lines pass. If R is exactly 1, then it's going to be in a line like so. So you have a positive line. All it is going to form an exact line. If R is -1, it's the same thing, except it's going down this direction. So this is exactly 1, and that's exactly -1. If there's very little scatter, it's closer to 1 and -1. If there's more scatter, it's closer to 0. So we can do this little quick number line thing. It's +1, -1, 0. Okay? This is weak, this is strong, and this is strong. So the more it's to the 1 and -1, the stronger it is. The more it's towards the middle, the weaker it is. So, if you look at these examples, correlation of 0, okay? With my analogy, where's the fly strip? Is the fly strip here? Oh wait, maybe it's here. Oh wait, maybe it's here. If you can't figure out any idea of where to draw the line, there's exactly no correlation. Now this one, you can see, it's kind of going down this direction. Now, is it strong? No. Okay? There's a bunch this way and a bunch this way. But you can see it's kind of generally going down that direction, hence why it's negative. But look how close it is to 0. Okay? Think about your grades. Would you be happy with a 30%? No, it's a failing grade. You want at least a passing grade. Okay? So you want to at least have 60, 70. Okay? This one, there's a line in there somewhere. It's positive. Not very strong. Okay? Here, well, there's a line right there. It's stronger. Okay? 70% on test. Pretty good. Here, much stronger. Way closer to the line. 0.9 and positive. And in this one, that's like a brand new fly strip. They're all buzzing around there. Okay? So but it's negative, but it's still very strong. So don't get confused positive and negative with weak and strong. You can have a strong negative and a strong positive. Okay? So,